Welcome back once again, friend. Here we are going to solve another, I think this is the fourth problem of integration by substitution method. Again, we're going to solve this in the sixth step as we used to do in the previous videos. And this question is just to make you wake up, ding 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 ding, ding dong, whatever. So wake up, because we're gonna use here now some tricks. In the previous video I told you just to use 6 steps very easily, but now in 6th step we have to start using little our brain. All right, see, the first step was look at the question, look at the independent variable. Yes, I take a look very seriously independent variable and the expression, that's x and x log x. All right, so that it will help you in the second step. So here I'm telling you now, while taking a look, you transfer your now I'm just saying you as an addition in this step first. It's as additional information, right? You need to make your question a little more suitable for solving second step. All right, what I mean to say that it's not like directly you will start from the question itself. You may have to transform, you may have to simplify a little to the question before going to the second step. Okay, you did first step, that's fine, but you need to now simplify as well, because here take a look properly. Derivative of x, that's 1, which is present here, but how you convert this all into the form of new supposition, let's say t, or if you suppose this x log x, then you're gonna use the product rule, and that's gonna be very big, and you may get these things, I mean the derivative you may get here or not. But if you use a little brain, what I'm saying, just see here, take a look once, it's dx. all right, and if you take x common outside, it's gonna be 1 plus log x. And now see how the question get very simplified. X derivative is 1, but you cannot still convert everything into the t format. But if you suppose this 1 plus log x as a new function, I'm talking about the second step. In second step, if you suppose t as a 1 plus log x, then what will be the derivative of this? Can you tell me? Derivative of 1, that's 0, which is already present here, nothing, that means nothing. All right, and log x, the derivative of log x is 1 over x, and this is 1 over x, means your derivative is already present. So we have to suppose our new function t in such a way that everything can be transformed into it form and into this t format, and your derivative should be present already there as well. We supposed 1 plus log x, whose derivative 1 over x is already present there. And now our third step is to differentiate this t new function so that we can replace this dx and we can get a good relationship. All right, so I'm just going to differentiate it, dt over dx, and it's 1, that is 0, and log x is 1 over x, and that's actually 1 over x. And now our fourth step is getting relationship, and our relationship is now that we can use here so that we can replace this dx and x properly. All right, so it's dt equals to dx over x, and that's our perfect relationship to replace something here. If you rearrange it properly, how it's going to be, see here, it's let me first write 1 over 1 plus log x, all right, times dx, and this x will be here. So this thing can be directly replaced by dt, and now our fifth step is replacing all the existing variables by the new term, in the term of t. So our integral is getting now 1 over 1 plus log x. 1 plus log x is t, so it's 1 over t, and dx over x, that's simply dt. All right, and now simple process of integration. So integration of 1 over t with respect to t is simply log of t, absolute value of t, plus some constant. Constant always come, that. All right, so this is 6th step, and replacing this t with original 1, that's our 6th step, that is 1 plus log x. So it's log of 1 plus log x, all right, plus some constant, and that's our final answer. This is how we need to do it. So in this video, actually you just learn one thing, ding dong. Means you may have to simplify the question itself to use the second step, to follow the second step. All right, keep that in mind. You may have to simplify the question itself.